Thank you, Chairman. My name is Yoshioka from Hokkaido University. Today, I'd like to introduce our research titled BERT-based ensemble methods with data augmentation for legal textual entailment. So in this talk, we would like to introduce our system that participates CORI 2021 Task 4 Statute Law Entailment Task. This is the format of the data for the task. A pair of questions and articles are provided. The system should estimate the label for this pair by checking whether the article entails the question or not. In this case, answer is yes. So recent development of deep neural network tech-based NLP, these tools are also used for this task. In the last CORI, the best performance system uses BERT as a core module. BERT is a tool that can be used for semantic analysis tasks by the pre-training for general semantic understanding tasks using large text corpus. Based on this training, BERT can be served as a general semantic analysis tool by fine-tuning with small training data. Even though the best performance system works well at the CORI 2020, but there are several issues remain. One big problem is lack of training data. We only have 3 small examples of 806 pairs. Another problem is variability of the question. The good performance system for the data of a particular year may not be good for the other year data. In order to tackle these issues, we propose a method to make new training data systematically. And we also propose a method that can handle variability of the questions. In order to make new training data systematically, we classify the type of mismatch for entailment. So this kind of data making process can be called as a data augmentation. That is a technique for machine learning by increasing the data using original data. There are 2 types of mismatch in the for making such a kind of pairs. This is an article. Is a judicial act performed by an adult word is voidable. So when we replace the adult word to adult, this is a semantic mismatch. We cannot entail the such kind of question from this article. Another type of mismatch is a logical mismatch, that is flipping the decision, adding not or removing not. It's not so easy to appropriate set of such semantic mismatch pairs, but it's much easier to make this type of logical mismatch systematically. Based on this understanding, we propose a method to create logical mismatch data systematically. For the positive example, we pick a pair of sentences about judicial decision in the article for the question part and article parts. The same sentences are used for these 2 parts. Negative examples are made by flip judicial decision of the sentence statement in the positive example to make logical mismatch. We flip the question statement. Most of the case, we add or remove not for the question statement for negative example. This is an example of making augmented example. This is the original statement. And from this statement, it says that may not. So we copy this statement to the article part. However, for the question part, we remove not from there. So because of that, this article cannot entail this question statement. So based on this training data, we train a BERT-based entail system that is for original that was proposed in the original BERT paper. In this framework, BERT estimates whether the question is entailed by the article as a binary classification task whose input is a combination of question and question and article with combinatory symbol set. The system calculates probability of entail or not as a result of the estimation process. So in order to understand the effectiveness of our proposed framework, we conduct preliminary experiments. This is a parameter of the BERT is as follows. So we use BERT Japanese model constructed by Inui's laboratory at Tohoku University with following parameters. We select minimum validation loss model using validation data. By using this method for 768 articles, so by using this data augmentation method, we construct 331 pairs generated as augmented data pairs. And we also split organizer-provided training data into training for the preliminary experiment, 695 pairs, and the testing for 111 pairs. And this training data are also split into training and validation 9-to-1. So we all have, finally, we have almost 4,000 pairs for the training. 70 sentences for 70 pairs for the validation and 111 pairs for testing. In order to checking about the variability, we made 10 models using different randomly selected training set. This table shows the performance of the generated models using validation loss, validation accuracy, and the test accuracy. As we can see, the performance of the system are not so consistent, even though we use almost same framework for training the models. In addition, validation accuracy is not directly related to the performance of the validation accuracy and the test accuracy. So it is difficult to select appropriate model using validation accuracy and validation loss. In order to evaluate, based on this understanding, we try to make a proposal for making an ensemble models. In order to evaluate the effectiveness of this idea, we also conduct preliminary experiments for ensemble setting. In this experiment, we check performance of the combination of different models for ensemble. In this ensemble process, the average probability of positive and negative from the target model and select one whose probability is larger. We calculate accuracy for all combination of these 10 models. We select the pair set that uses 3 to 10 models from them. This table shows the result of the ensembled data. The best performance system uses 7 models, and the second and the third best system uses 3 models. On the contrary, the performance of the system using all models is worse among all settings. From
Mr.
this result,
Yoshioka,
yeah.
You have 2 minutes.
Yeah, thank you.
Sorry.
From this result, we found that simply adding of the model may not be good for improving the performance. So it is necessary to have a mechanism to select appropriate set of models for ensemble. So we use evaluation data because these 2 sets are good for the testing of the training data. We're picking up these pairs for the one of the best performance system of the submission system. We submit 3 results with different ensemble setting. Our system achieves the best performance among all submissions. From 81 questions, we can answer correctly for 57 answers. The accuracy is at 0.70. And we also compare the performance of the accuracy of previous year's data, the model is not so consistent. However, when we compare the result of the system with other participant system, our 18 runs are submitted in total. It means these questions are almost all system can answer correctly. And these questions are questions almost no system can answer correctly. Our system is very good at making good answers for the easy question, but we still have a difficulty to answer that difficult question. This is an example of the difficult question that includes semantic matching, anonymization, symbol treatment, and so on. So BERT model itself can handle some semantic information, but there are so much big semantic gap between this question and articles. In such a case, we fail to analyze such a kind of statement at this moment. So this is a summary of my presentation. We propose a statute law legal entailment system based on BERT with making new training data that consider logical mismatch using systematic approach as data augmentation. We also propose a method for selecting appropriate set of BERT trained model for Ensemble. We confirm the effectiveness of our approach using pre-2021 test data. Thank you for listening. This is the end of my presentation.
Thank you, Mr. Yoshioka. And now we are going to the question and answer session. The first question is, for a legal perspective, is it possible to analyze and relate the outputs, yes or no, of your BERT-based system to any possible legal explanation to that?
Yeah, it's a very important point we have to discuss. At this moment, since our system just say yes or no, so this is just a starting point, and maybe you can see some neural network, deep neural network based analysis. Maybe we have to think about such a kind of attention. So these two parts may be related or something, can be lead to such a kind of explanation. But at this moment, we cannot start such a kind of analysis. So yeah, at this moment, this is just a result without explanation. So we also think about how to generate explanation based on this result later.
Okay. And the second question is, can you think of difference between the Japanese judicial system to another law system in the world, like the American? And if you did, do you have suggestions of adaptations you could do to your work?
Yeah, so yeah, in the Korea task, we have a Japanese version of statute law task and the Canadian case law task. So the case law task have a much more case oriented. So most of the case, statute law only mostly contains the legal terms. The difficulty is the matching between the legal terms of normal terms exist for the cases. But case law matching, we also think about some matching of the normal terms and normal terms that consider the role of the judicial legal terms and so on. So the situation is not so, maybe it's not easy to say this is for American, this is for Japanese, but for the case law and the statute law, there should be some difference.